For this question, we're determining whether or not some of the compounds we're given exhibit at least one bond angle that is approximately 120 degrees. So first, we will need to determine the geometry of all of these compounds. So let's take a look at some of the examples we have. So for xenon, for XeCl4, our central atom will be xenon because it is the least electronegative atom in this compound. And we have a total number of valence electrons equal to 36 because we have 8 electrons coming from the xenon, and each of the chlorines contributes 7 electrons. So knowing this, we might draw our compound looking like this. So we know that we have 4 chlorines that are bonded directly to the xenon, and if we assume each of these chlorines have a full octet, and since there are 4 of them, 4 times 8 equals to 32, and 32 subtracted from 36 gives us 4 remaining electrons, and we could put those, or we associate those 4 remaining electrons to the xenon, so that means 2 lone pairs that are also coming from the xenon. So in this case, if we take a look at this compound or in this geometry, each of the chlorines are about 90 degrees away from each other. So in this case here, we don't have any bonds that are around 120 degrees. So moving on, let's take a look at another example. We have ICl5. Our central atom will be I because it is the least electronegative atom in this compound. We have a total number of valence electrons equal to 42. So we might get a compound that looks like this. Again, in order to figure out how many lone pairs you should attribute to the central atom, you can assume each of these chlorines here have a full octet. I didn't put all the electrons, all the lone pair electrons on the chlorines, but you can imagine if they were there, they will have 8 electrons surrounding each chlorine. And because there are 5 chlorines that are directly attached or bonded to the I, 5 times 8 equals to 40, so you're left with 2. If you subtract that from the 42. So both electrons go to the iodine. And in this case, we have a pyramidal structure or geometry here where these atoms are about 90 degrees away from each other. So this chlorine to this chlorine here is about 90 degrees away from each other. And these neighboring chlorines here in the equatorial position are also about 90 degrees away from each other. So in this case, we also do not have a 120 degree bond angle. So moving on, we have IF3, our central atom is I, total number of valence electrons equal to 28. We might draw a structure that looks like this, is a T-shaped structure. And if you have 5 different electron groups that are bonded to a central atom, and 2 of those electron groups are lone pairs, the most common structure or the most common geometry that you would see for this would be a T-shaped one. So knowing this, we can tell here that each of the fluorines are about 90 degrees away from each other. So here again, we also do not have a 120 degree bond angle. Let's move on. So KrCl2, our central atom will be the krypton, and the total number of valence electrons we have will be equal to 22. So we can draw something that looks like this. This is going to be a linear compound, and the krypton will have 3 lone pairs surrounding it. So in this case, the 2 chlorines are about 180 degrees away from each other. That is a bigger angle than we're looking for. So also, this will not be a yes for our question. So looking at PCl5, our central atom is 5, total number of valence electrons is 40. We can draw something that looks like this. Our phosphorus has 5 chlorines bonded to it, and it will have no lone pairs surrounding the phosphorus. So in this case, each of these equatorial chlorine atoms are going to be about 120 degrees away from each other, and these equatorial and axial chlorines are going to be about 90 degrees away from each other. So in this case, yes, we do have a bond angle that is 120 degrees in this compound, or in this geometry for this compound. For SeF4, our central atom is Sc. We have a total of 34 valence electrons. Our Lewis structure might look like this. because we again have 5 different electron groups bonded to the selenium. And since one of them is a lone pair that's bonded to the selenium, the most common structure you're going to see is a seesaw. So in this case, our two fluorines here in the equatorial position, they are about 120 degrees away from each other. So in this case, yes, we do have a bond angle that is 120 degrees. So finally, we have SeF6. So our central atom here actually should say Se, selenium, not I. And we have 6 electrons that are being contributed from the selenium and 7 electrons from each of the fluorines for a total of 48 electrons. And we get a structure that looks like this. This is going to look like an octahedral group. And if we take a look, each of these fluorines are neighboring each other about 90 degrees away. So nowhere here can we find a 120-degree bond angle. So the only two that answers yes for this question are the PCl5 and the SeF4.